What up? What up? I'm back, and today we're gonna be doing exactly the same thing as last video, solving 3 coding problems. Yes, we solved 4 last time, but 4 I think is too much, and my dad also agreed. So we're gonna do only 3, and today there's gonna be a special surprise a little later, not the end, but like a little later. So yeah, let's just get into it. Now we're gonna solve, as you can see, day 3, bronze 2 problems. Now last time it was bronze 3 and bronze 2, but we're gonna just do bronze 2 this time. Okay, so this is in English, so I'm gonna give you the pause video. I'm gonna show you how to solve this one. Okay, there's this number that is n, which equals the number of cars. Now let's say this was 4. Card 1, card 2. These are terrible card drawings, but this is the best I can do. Card 4. And as you can see, you have to go where this, well, in blackjack, which is a popular card game, so blackjack. In blackjack, you have to pick the number of cards that is less than or equal to 21. In this game, however, what you're supposed to do is that there's a specific number of cards, and these numbers have some random number on them. Something like that. So what you're supposed to do, there's another m. This is n and this is m. Let me just make sure that I'm saying that. M is equal to any number that is less than 300,000. 700. Now, there are different ways to get below 700, but we're trying to find the smallest, the largest values that are possible. And to do that, it's pretty easy. Let's try to solve this one. Now, I already know the answer, because it's 621 plus 61 plus 7, which really is equal to 689. There's no other way to make it bigger. Now, 689 is the biggest number you can make, and that is smaller than 700. So that's how it really goes. Now, we're going to solve this problem. Okay, I think I finished. Let me just explain what everything's happening. So this is N, M, N, and M, and we're inputting in N, M, M. This is the cards. We have to store in an array. This is the max value, which is originally 0. So we're inputting cards of I, and then we want to do this because we don't. If we do it in another for loop, then it will take more time. But instead of taking more time, let's just do it right now here. And so we are just checking which 3 numbers now. But it does have to start from here. So 765, and then it goes something like, that's probably it. Yeah. And then 876, and then 865, something like that. 987, 976, 965, and like other orders, they're exactly the same as those, just differently ordered. So that's just it, and we're trying to find the max value. So yeah, and here is where we sit. This is the if statement where it says if the 3 values we've chosen, which is these 3 values for the for loops, and if those 3 values, if added, is less than or equal to n and bigger than max, then we're gonna say that max is equal to cards of I plus cards of j plus cards of x. I also put this here because we want to make sure that if cards of I plus cards of j, which we already picked, if they're bigger than m, then already that won't work, right? But yeah, less than equal to m. And as you can see, and this is space positive integer, so I don't need to worry about negatives. So let's just test this theory. Let's just test if it works. 21, yes, correct. 497, as you can see. Okay, let's just put this in. As you can see, that works. Okay, now I'm gonna put this in Java, which is pretty much the exact same thing, just a teeny bit different. Oh, I see. I destroyed the string tokenizer. String tokenizer is when I add inside using inputs. I'm putting this in Java. If no one actually knows that, I'm putting it in Java as well. Yes, Java was my prime. How do I say this? Prime language. So yeah, let me just change it. I believe that should work. And let's check this. Yes. Of course, God. Add this because new line and don't worry about these. These are error signs, but should be fine. They're saying that there's an error, but there is no actual error, so that should be fine. Let me just check that this is correct, and remember to change the language. As you can see, that's 132 milliseconds versus 0 milliseconds. C++ is way faster. Oh, yes. Let me show you something. You might be like, what are you holding with a plastic cup with lettuce dirt in it? Well, do you think we have a new pet? We have 4. And you might be like, what are they? Let me just move a little so maybe you can't see me, but story right here. We found a slug inside a cabbage, and we named it Dandy. Because it died next week because we put it in a cage and then it went outside a hole out of the cage and dried up. Sad. But so my dad ordered 4 more slugs, and this is one of them. Ty and I keep 2 each, and we name each of them. I'm gonna show you one of them. Side note, he's called Lucky, so okay. Let me just show you if you can see right there. That's him right there. That's him right there. I'm not sure if you can see it because there's a camera, and I can't see in front of the camera, so I'm not sure if you can see it, but I'm trying my best for you to see it. This is the flash. Oh, can I show you? Yeah, let me try. But if you can see, he's actually inside there. I can't specifically point where he is, but he's about in there. I'm not sure if you can guys see it, but yeah, he's in there. I'm shaking very much because I'm trying to keep them still. Well, this is one of Sally's. Her name is Swifty. Oh, yep, it's right here. Oh, this is very difficult. Let me just set the table for a second. It's right there. Right there. Sorry for sometimes it's shaking. That's him right there. Or her. Oh, fun fact. For slugs, doesn't matter if they're female or male. Until they meet, they give tons of birth. And we've never experienced it, but we know that for fact. So do not put 2 slugs or snails together. Do not. This is Dandy Jr. As I said, our first slug name was Dandy. So I named it Dandy Jr. The youngest, actually. So I'm sorry, but I can't actually show you Dandy Jr. That's fine. Anyway, that's 4 slugs we have. Dandy Jr. is in this cup. Yeah, sorry, I couldn't find Dandy Jr. So yeah, that's the 4 slugs. So let's just go back to, that was a special surprise, by the way. So yeah, let's just go back to our 3 problems. We solved one of them. Now let's just solve the rest one. 10809. 10809. Yes. Now this is in English. English. Oh god, I can't speak today. This is in Korean, so I'm gonna translate it in English. I'll give you a second pause. On pause. Now. I'm gonna. Now, how we're gonna solve it is there's a word that's S. So there's a word that is S. And it's like N, but it's an integer. This is S, but it's string. Now, it is made up of only lowercase. And that's actually really good because for uppercase, we need to do both. Now, to solve this problem, let me just, I think you all understand the problem itself if you looked at it, but you have to find the positions of where it starts. So, the first A, B, C, D, E, F, G, I, J, K, L, M, N, O. Oh, right? 0, 1, 2, 3, 4, 5. 5, right? That's because it's 5 because it's the first appearance of O. That's how it is. So what we're gonna do is we're gonna use an array to store every single value of the alphabet. And this is a terrible one because there's 26 letters. Now, and then we're gonna store each of them. Now, A. And remember, we're not storing how many there is. We're storing the position. And they start from 1 to S dot length. So if the alphabet is not included in the word, then we just output -1. That's just it. Alright. Now simply, as I said before, we're gonna put everything in this order, right? I'm gonna show you how. Well, not really show because I gotta write the code, right? Sorry about that, but just look at the code and I'll tell you how. Oh, I forgot to tell you one thing. We're gonna use ASCII, which is really changing a character to an integer. So character A turns into 97. So we can store those values. Okay, I'm done. Let me just tell you how this goes. This is the alphabet, and this is the position store. And I put every single value in the alphabet as -1. Oh, by the way, this is S. Putting in -1 because if the position is not equivalent, and if I change this all to 0, that means what if the position is 0 and it could get worse, right? So I did this everything to the -1. So if it's not there, I can immediately just print it out here. And why I did like I less than 25 and do this because as you can see here, you don't put a space after the last value. So you're gonna just do a new line at the I can't speak last value. So yeah, that's why I did that. This is technically the ASCII code. So this is the ASCII. So S of I. What this does, even though S is an array, this changes the specific character into a character. Now this changes character. This changes the character into an integer. And then remember, -97 because A is the first character in the alphabet. We put it in position 0 of this array, so -97 because the ASCII is 97. And if it's equal to -1, then it's just going to equal position. I'm going to copy. That looks correct. Yeah, I'm going to say that's correct. Yeah, that looks about correct. Now, because we did C++, we gotta do it in Java. I know you might be like, seriously? It doesn't take that long, and my dad said to do it, so, there's one thing in Java that I really don't like, is that it's so much harder. It's not harder, but, like, there's so many easier things C++ does. And, let me just say, and is faster. C++ is way faster. So I'm like, why not use C++? Right? So I learned C++ after doing Java. And as you can see, it's okay. You know, I always have to check just in case there's a problem. You see. Now, you also have to capitalize S in the first string. And it's again saying S of I. Oh, yes, I know why. The character value of S is of string I, I plus 1. It is also much harder to do just that. There are some things that you do have to change. And it's gonna say like, what is STR? So string called STR. Trust me, there is. Okay, now it should, I think, sure. Please. That doesn't look like work. Oh, because it's already at 0. That looks about right. Ooh, sorry. Ooh, this is in Korean. Sorry. Yeah. I mean, I didn't change it. It's just that when each time I change like the page, like going here to here, it just changes it to. Oh, good. You see what I mean? Look at how slow Java is. This is 0 milliseconds. This will be like 144. I only say that because this is 144. It usually doesn't go this slow. It's not 1 second probably. No. 148. Okay, so we saw both in Java and C++. Now on to the next question. By the way, if anyone asks, that's what Network Chuck does. Yes, I copied his, but it's all yours, right? Network Chuck, if you're watching this is your move, right? It's not mine. I'm not taking copy. Well, I'm not taking like, yes, I did this. I made it up. This is my idea. Network Chuck made the idea. I'm just following him because, you know, I like to. Okay, so I'm going to give you a second to read it on pause. Pause. On pause. Alright. Anyway, right? Oh, I don't want that. I'm going to get my special pen tool right here. And I'm going to draw something for you. How to solve this. Okay, how to solve this question. There's 10 students. Okay, so the highest score among K people will receive an award. So if one person 100, then this guy will get an award. Find out how many points the cutoff is for receiving the award. Cutoff is the score with the lowest score among the recipients of the award. Now, of course, the number of candidates is N students, and K people got an award. Award. Let me just specify that. Oh, there we go. Award. Now, if a person got 100, they're definitely getting it. So what we're gonna do is, as you see, it does give this limit. So n is less than 1,000, k is less than or equal to n, and then x is less than or equal to 10,000. That doesn't really matter for that. It's just that if N was crazy big, then I would be like, holy chocolate. Anyway, so yeah, that's it. Oh, completely forgot how to solve this question. Now we're gonna put every single student in score inside, right? And then we're gonna go, and then we're gonna sort, which is a specific function that C++ and Java both do have. So now after sorting that, that means it's going to go from the lowest to the highest. Now you want, for example, 2. What you're going to do is you're going to do array. Let's say the name of the array is array of. That's it. Because this is actually n minus 1. Because you can't actually because it starts from 0, it ends with n minus 1. So you just have to do n minus k, which is great, right? I don't know. But that's how we're going to solve it, essentially. Yep, that's it. I'm done. So this is n k, this is the array. Inputting inside everything goes like this. This is sorting the array from smallest to biggest. This is just printing out. Now, yeah, there we go. You see. That's all the test cases there is. I would recommend using C++ instead of Java, just because C++ is faster. You see, that it was like instant, right? Yes, you don't know what sin means. Yes. Those integer parse in. Oh yes, there's also a new one where it's a new one. You have to do this way. I don't know why. Also, there's also a thing as a sort, but there's an erase of sort. And you don't even need this. Huh. Good water. I believe this is all I need. I'm very like, I voice. Oh, yes. I always forget, add this when there's a new line of input. I just forget in Java sometimes now because, I don't usually code in Java anymore. Oh, yeah, there you go. Yeah, I don't usually code in Java anymore, so, right. Also, Java 15 and Java 11, I'm pretty sure there's no difference. No, there's definitely a difference, but, it doesn't really matter if you put it. Alright! I am done today. I have solved every single question. I solved 3 questions, right? Yeah, I solved 3 questions. So I've solved all questions today. I've written in C++. I've written in Java by changing it a little. I've done everything. I want you. And I also drank water. Showed you the slugs. And the thing is the end. Oh, God. Great. That's finished.